Hi, everyone. Welcome to Data and AI Trends for 2021 and beyond. We are thrilled that you are here and joining us today. We have such a wonderful discussion ready to go for you all. My name is Emma Jordan, and I'm a marketing manager at staffing and recruiting firm Motion Recruitment, the founder and sponsor of Tech in Motion events, which is, as most of you know, our international tech event series, the reason we're here today. For those of you who might be attending with us for the first time, Tech in Motion is a community-driven event series with the goal to bring together our tech communities from all over, share ideas together, and inspire one another. Today, we have a great topic to go over. I'm so excited and interested to hear what our panelists have to share. As we all know, innovation in data and AI is accelerating rapidly after a crazy year that brought radical change to the world's data needs. In fact, because of this, about 75% of enterprises will shift from piloting to operationalizing AI by the end of 2024. As many of our traditional models for data management and analytics are becoming outdated, many new techniques have emerged that are helping organizations and society deal with the disruptive changes we have all seen. Today, we will get the chance to hear from top data and AI experts about what new trends, tools, and strategies have emerged and are here to stay. So before we get into our wonderful discussion, just a few housekeeping items to go over. As the panel gets started, feel free to submit any questions or comments in the chat box, and our panelists will do their best to get to them during the event and during the Q&A session at the end. Today's webinar is also available on demand and is being recorded. So for any reason you got to hop off, your kids are begging for something, you have another meeting come up, don't worry, you'll receive the link to your email so that you can watch this video afterwards. And last but not least, please follow us on social media so that you'll be up to date on all of the wonderful upcoming events and opportunities we have for you to get involved with us. Okay, with that being said, on to the good stuff. I would love to introduce to you our moderator, Eli Young. He is a passionate futurist and emerging tech evangelist who helps organizations ideate, strategize, and deploy innovation AI projects. He has an expansive and wonderful career, and he's been able to work with large clients like Virgin Orbit, Hyundai, Kelley Blue Book, and more. So excited. So I'll pass this off to you, Eli, and you can get us going to our discussion.
Awesome. Well, good morning, good afternoon, good evening, or for those of you that are listening on the webinar replay, hello to you, whatever time you're in. Super excited to be here once again. Emma, thank you for you and the team inviting me back to host and moderate this event. We're going to go ahead and get started, and thank you again for that wonderful introduction. Yeah, so a couple quick things on me. I'm really a futurist. I'm really a tech geek nerd futurist, and it all starts with curiosity. You know, when I was a kid, I was the guy that took apart brand new toys that my mother would buy, or like, I'm dating myself, but when I got a computer that was very, very expensive back in the day, I took that apart. I mean, if we're talking about old school, I'm talking about like a 486 kind of computer. But the thing is that curiosity is what fuels innovation, right? And I think most of us would agree. I think in our human race, exploration in general, right, the ability to explore our environment and then try to wield, you know, circumstantially be able to wield power and authority over those faculties and facilities that are all out there, right? So we try to think about AI through that lens of like, hey, are you curious about what the world is going to look like in 20 years? So for me, I start there. Like, I'm looking way out in the future into quantum computing and all of those types of things, and superposition, and what does that mean? And, you know, some folks were really big in string theory a bit ago, and that's somewhat, you know, out there. But, you know, there's a lot of things out there that if you're interested and you have curiosity, you can do anything because the information is available. So that said, I want to introduce some phenomenal speakers that we have for you. And I'm going to start with Akshaya Aradhya. If you could just share a little bit more about you and what you're up to. And then, yeah, we'll pass it to Colleen after that.
Sure. Hello, everyone. It's a pleasure to be here. And thanks, Eli, for introducing yourself and telling us all the cool stuff. This is Akshaya. I work at Netflix as the director of Data Platform Edge. What I do is my org works really closely with data scientists, machine learning engineers, algorithm engineers, data engineers, and a bunch of business folks who are totally non-technical and want to provide different types of solutions that cater to different types of audience so that they can use data and analytics to understand what kind of shows are more relevant to a particular audience in a region, or how to channel your marketing spend this way, or how to form collections of data, or help other engineers do queries faster or understand the information in a much better fashion. We also have some open source tools that people have used, like Papermill, Moleskin, and our Jupyter Notebooks community engagement is also quite large. And that's what I've been doing at Netflix so far. I'm based out of San Francisco.
Awesome, thanks for that. And I apologize, Colleen. I'm actually going to pass it to Joseph because I see on the slide here he's next. So we're going to go ahead and follow that. Forgive that. But Joseph, let's hear from you. Tell us a little bit about your background and what you're up to.
Absolutely. Thanks, Eli. And hi, everyone. My name is Joseph Davis. I am currently the lead data scientist at FMC. And so for the folks who are not familiar with FMC is an agricultural science company that develops agricultural solutions for a number of farmers slash growers around the world. And what those solutions look like is, various packages of sort of like, pesticide solutions. So that could be insecticides, herbicides, fungicides. And so, there's a lot of work around how the stewardship of the products are used to, better, how they're used better. So my role at FMC is to develop the vision for how we use machine learning and data science to move our agricultural science problems forward. So what does those agricultural science problems look like? So today we're focused on looking at pest forecasting. And what that looks like today is there are insects that are causing billions of dollars of damages to crops as growers seek to grow these. And what my team does is forecast or sort of predict the outbreak of where these insects would typically end up within a field so that you can apply your application at the right time so that you can minimize not only use, but also the ability to which insects develop the resistance to these applications. And so we also look at some computer vision problems, which involves identifying insects that are captured on sticky sheets from various traps or sensors that are placed in these fields. I'll probably talk a little bit more about that later on, to identify what that looks like, and then being able to count and send those to our predictive models for forecasting or prediction. So that's a little bit on sort of the FMC side. I do have experience on the e-commerce side, building recommender systems and also dynamic pricing models. And so, be happy to kind of get into any of that later on when the discussion, when we're relevant. Additionally, I also serve as an adjunct professor at St. Joe's University, where I teach a graduate course in Introduction to Data Mining. And that's also a place where I enjoy distilling my passion of just explaining these complex topics in really more simple ways. All right, so that's a bit on me. So I'll turn it back over to Eli. Thank you.
Thanks so much for that, Joseph. Let's go to Colleen. We'd love to hear your background and what you've been up to.
Hi, I'm Colleen Farley. I am a senior data scientist at Data Assembly, which provides our consumer packaged goods clients with hyperlocal pricing on different items of interest to them. So a lot of the work that I do is working with text data related to products from different banners at different stores and how to classify them, how to match them between different stores and private labels. And that's kind of what we're working on right now, along with some other analyses that can give insight into how pricing varies. My background also includes topological data analysis, a lot of network science and quantum computing. And I worked in a variety of industries before consumer packaged goods, including genomics, healthcare, marketing, defense, and a few others.
Awesome. Well, thanks, Colleen. Glad to have you here. I also want to share a little bit more about my background really quick, because I realized I didn't really give an intro about me, because Emma did that. I'll just share this. So I'm Director of Innovation and Strategic Partnerships at a company called Atmex. We're based in Silicon Valley, but we have offices pretty much all over the United States, and we're in pretty much every time zone in the world. We have 3 big centers in India as well. So we have offices in Dallas and in Phoenix and New York and Florida and all those things as well. But I'm based in Orange County, California, if I didn't say that already. And really what my job at Atmex is to do is to help, I'm customer facing. So it's really to help our customers to light up AI projects in that whole process of what it looks like to ideate and start with an idea or a problem statement and take that all the way through production and to, you know, support and maintenance on the back end. So that's just a little bit more about me, if anyone's curious about that. Also, I serve as a board advisor at UC Riverside, University of California, Riverside, in their design thinking program. So if anybody has interest, please talk to me about that. Design thinking and composable architecture and infrastructure. Those are some of the new things that are coming forward. And so just keep that in mind. If anyone's interested in, like, we're going to talk about some of that a little bit on this call, but if you're interested in learning more, reach out to me. I'd love to tell you about the program and other things like that. And also, if you're looking to do some sort of project or something, you just have some questions, man, I can be a resource to you. So let me know. Reach out to me if you have any needs or issues for that. Okay, so
can I quickly, you reminded me, I'm also on the board for Cal State East Bay and previously for SFSU for the big data program. So I'm happy to chat about that. And, you know, I recently got my Wharton MBA, and I'm in touch with a bunch of people who are trying to get their ventures up and running. So if you need anybody to weigh in on any business ideas or like give you another informed opinion, please feel free to contact me.
Yay, thanks for that. Actually, that's awesome. All right, so let's just jump right in. We're going to start with this first question, and I'm going to direct it kind of to everyone. And so if you have a perspective and you want to share, just go ahead and start talking. It's all good, okay? So the first question is, what does the data and AI landscape look like in 2021 from your purview? Anybody want to take that?
Yeah, I can start. So the pandemic kind of shaped how we look at the trends in the next 2 to 3 years. In fact, when I was managing the data platform for an ad tech company called LiveRamp 2 years ago, if you had asked me the same question, I'd be like, yeah, probably, you know, we could be like operationalizing the business value through more effective XOps or creating more smarter and responsible AIs. But then the focus shifted more and more towards big data, and then from big data to small data, and then small data and wide data. So what we are trying to do is we want to think about how you know, you can leverage small data to offer useful insights while including certain time series analysis techniques or few short learning or synthetic data or supervised learning or whatever is applicable here. And in terms of wide data, we could also think about enabling the analysis and synergy of a variety of small and large unstructured and structured data sets, and you know, think along those ways. In fact, I'm seeing a trend where IT departments are, you know, usually struggling to manage and mine the unstructured data and making it a challenge to extract actionable insights. So around 80% or more, if I'm not wrong, of unstructured or enterprise data is growing at a rate of like 55 to 65% a year, as per the recent study. I think it may have been stated in Data Motion or somewhere else. And companies are starting to embrace AI. I can talk about how we kind of use that for our marketing spend or analyzing where to, you know, spend our cost, especially when you're talking about billions of dollars and scaling the consumers to a couple of more millions. And that's where AI and machine learning and robotics come into picture. And you want to, as a company, you would want to make sure that you get the full benefits of the AI and start educating your workforce on how to use that and leverage data monetization to create new revenue streams if you haven't done already, or adopt cloud for even like multiple different use cases that we haven't thought of, because by in a year, I think by mid next year, you would need public cloud services for 90% or more of data analytics innovation. I think that's where the trend is, shifting more towards. And of course, graph analytics. Graph is being used for almost everything, everywhere. I think Facebook led some initiatives for developing their own graph APIs. We are working on something similar, and that's also a huge trend that we are focusing on.
Thanks so much for that. And just speaking about data, the cloud, hybrid cloud, on-prem, off-prem. I mean, we moved from these big giant, mainframes to data centers to this. It's becoming, to your point, it's becoming smaller and smaller and more cloud-driven and more cloud-native and these types of things. And so, Joseph, I've got a question for you in terms of, how do you address the cloud at all? Like looking at, hybrid cloud and edge and IoT and those types of things. Share with us your perspective on what you guys are up to there in that space, because obviously I know you're using AI at the edge. Of course, if you're out in the fields, right, and pest mitigation and all those types of things, or when you need to deal with an insect, to your point, and all that stuff. So share with us a little bit about what you guys are doing there.
Yeah, absolutely. So I want to connect to Akshaya's point earlier, and then I'm going to come back and connect answer your question directly, Eli. So where does data and AI, the trend looks like, at least in agricultural science or agricultural technology today? I thought I'll touch on that for a little bit, because it's not something that you look at and as transparent as many industries. So I thought I'd talk about that for a little bit. So today in ag tech, the focus is really, or sort of the trend really is starting to collect data in an efficient and operationally scalable way. So what do I mean by that? Today, we have, various ways you collect data from farm, right? You have sensors in farms. Sometimes there's areas where you're using probably satellite imagery, maybe to look at biomass. You're probably looking at maybe drones, but some of these are expensive depending on what you're doing, right? And so the trend is moving from sort of like manual processes where you have an agronomist or say a scout that goes out to a field or a farm and is probably taking a picture of an insect or looking at the leaves and try to figure out how can you do this in a way that's more efficient. And so looking at maybe smarter traps, right? So stuff that's in the field that automatically connects the network, does picture taking and send this back to, or data centers for processing, and ultimately we send that data back. So that's sort of like what the trend is looking like, being able to collect that data in a more efficient and operationally scalable way. So that's where it's going. So now direct to your question now, Eli, around in terms of processing, right? Like as far as hybrid cloud or the edge is concerned. So right now we are in our FMC, we're partnering with various companies who are advancing technology in this area. So I want to talk specifically about how do we know in a field whether or not insects are present, right? So one of the most traditional way you do it is you set up like a trap, and it could be like a typical delta or a pheromone trap that sits there with a lure. And of course, a insect is attracted to a certain pheromone because that's the sort of like the hormones that the female bug gives off, and it attracts the male, right? So you can capture them and you can see the adult presence in the field. But that process is rather manual, and it can take a long time to do it. And so you probably don't do it often. And as a result, you're missing some days, and you make assumptions that sometimes aren't necessarily true because the environment is very dynamic. So what's happening today with that is partnering with companies and even looking at technologies ourselves to figure out how can we do this in an automated way. So how could you put a sensor out there that's automated? And what I mean by that is a sensor that is able to perhaps maybe even detect the spores in as far as disease is concerned from a plant and figuring out the signature of that and saying, oh, this is maybe, say, Asian soybean rust, right? Or whatever that is. Or maybe having a trap out there that's automated that captures, a certain insect, takes a picture and sends it back to your data center. Or if you're talking about that now, sometimes these farms are in rural areas and so connectivity is really poor. And so do you do the processing right there on the actual sensor in the field? And so what does that look like? And so these are some of the problems we're looking to solve today. Right now, a lot of them are getting sent back to data centers, but some of this is done actually at the edge, right at the device in the field. So that's sort of like my little take or perspective on that right now.
That's great. That's actually brilliant. I think about the overuse of pesticides, and I mean, think about as a society for thousands and thousands of years and generations, we have manually done these processes, but just in the last 20, 30 years, we started to automate with, on top of the machinery that's used. Now we're going to this hyperscale, if you will, where we can pinpoint through services like computer vision algorithms and things, to your point, that we can start to mitigate those pests and see what pests are in the field, right? And then beyond that, we can do all kinds of cool things like know how much we need to spray, right? Because I think we're all concerned about pesticides, herbicides, fungicides, all those types of things. And we know that they're somewhat essential depending on the crop varieties, all those things. But at the same time, it's a little scary to think about how much we actually can ingest, right? So to be able to mitigate those things using AI is actually a great help. So that's awesome. The next question I'd like to direct to Colleen, and it's the same question really about trends, but specifically, I know you've done some work, Colleen, specifically with quantum. And so some folks on this call have no idea what that looks like. So if you can just give us a nutshell about what you've done, your exposure to quantum computing, how you use that, use case scenarios, share a little bit more about that.
Sure, thanks. I've done several research projects with different types of quantum computers. So basically, instead of having bits that only take the values of ones and zeros, you can have qubits, which can rotate around to other values besides 0 and 1 and can actually be superposed. So instead of having to work on combinatorics problems in sequence, you can basically do it in parallel. It's a little bit like a map reduce built into your hardware. And that's been really interesting to look at for different graph problems. A lot of those don't need to be translated much to work on quantum computers, to look at cut algorithms, to look at flow algorithms on graphs. And a lot of other problems can actually be mapped onto this graph structure and solved with quantum computing. So one of the projects that I've currently been working on involves a nuclear core loading problem. So looking at the assembly of fuel rods within nuclear reactors. And by mapping this problem onto a graph that fits within the quantum circuits that exist today, right now, I think we're up to about 250 qubits in a quantum computer. Being able to map the problem from this really high dimensional combinatorics problem to this smaller dimensional graph lets us leverage this new technology to really be able to search the space in a more efficient way. And we've seen some gains from this, and we've also seen some gains from hybrid algorithms where quantum computers are basically simulated in classical systems to get the gains of quantum computers without actually having to use one. So that's been a really interesting development. And I think we'll see a little bit more of quantum computing in more mainstream data science as the technology progresses and the circuits get bigger.
That's great. Yeah, I mean, that's really cool. I mean, what a cost savings and honestly, like working with nuclear reactors, we definitely need. a little bit more help there, because I know that some of those, some of the infrastructure around that obviously is being reactive and then having a lot of issues. And I don't want to go too deep into that, but we know that basically with what you're doing and how you're helping to understand, you know, what's going on in the nuclear space, that you're definitely being a huge contributor. So I appreciate you sharing that. I want to move to another question around data specifically. So if we're talking about data and AI trends, we have to think about that in terms of the data itself, governance, prepping, cleaning, obfuscating when needed and necessary, if you're HIPAA compliant, or all these types of things to be HIPAA compliant, right? If you're, you know, if you have sensitive data, you know, or these types of things. Now, obviously, with all the new things with GDPR and CCPA, you know, all the different things that we have to deal with now, data is becoming more democratized in some capacities, but at the same end, it's still very necessary to have very clean data. Now, I know some people in some camps will say, oh, we could just take all your unstructured data and, you know, using our service, and we can structure that data to give you better insights and outcome on your algos. So my question is, you know, how are we thinking about data governance frameworks, prepping, cleaning, all those types of things? And then let's take that one first. How are we thinking about that? Anyone have a particular perspective on data governance, how that's used inside the business? Without giving too much secret sauce, right? But how's that working?
I can take
and I'll
that one.
Anybody wants to. Yeah, go for it.
Yeah, so at Netflix, we have our strategy is to grow from 200 million subscribers that we already achieved back in late 2020s to 500 million subscribers by the next 2 to 3 years. So we are also expanding our operations overseas in different countries or continents, their own compliance and data security logic and all the legal stuff that we have to follow keeps on increasing. So when it comes to data platform, what we wanted to think about was how do we as Netflix look at or classify our data operations. So there are like 6 components that we consider while thinking about data governance at Netflix. One is how to manage the data, the security, the privacy, or you know, the efficiency, compliance, infrastructure, and think about all of these things and use that to first of all understand what kind of data do we have, why do we have it, where does it come from, how do we collaborate on that data, you know, some should be greater than the parts, and how do we execute or get things done and all of that. So in terms of achievements or as an organization, what we kind of worked on was our data set classification in the very beginning. So we started sampling infrastructure for data detection on big data warehouse, Elasticsearch, Keystone, and RDS. And then we started improving our data lineage models, and we did S3 risk assessments and data classification integration. And then we started thinking about policy management. How do we actually look at this whenever we expand our content, or whenever we start streaming our content in different regions? So we started looking for a schema for data in motion in real time, and data provenance, and how does compliance look like in those regions, and you know, how do we actually revise our secure data warehouse logic for data processing and data storage at a very large scale. And there's still some confusion. There's still some confusion when it comes to the clarity on roles and responsibilities for different users, and how do we approach the security aspects of things. For example, data classification rollout was supposed to be quick even at this age and at this scale, but it took us a while as an organization with such massive scale of information to granularize the data elements, define how it needs to be, and detect the the sampling data to validate and verify findings and have confidence in our results at the same time before we start pushing them to data owners, and how it impacts different data different data sets and different projects within the engineering capacity in different business units, because we did need to identify accountable leads and infrastructure capabilities to make sure that the data governance logic is rolled out to different places. But I think all in a nutshell, data governance is one of those things that is going to be front and center as and when we start discussing more and more about what consumers want, how privacy laws change, and all of that.
That's great. As I think about data and data governance, there's companies out there have to almost retool or reorganize because data, and a lot of times, as we all know, are in different silos and different business units, and the ownership, right, if you will, of that data is well protected by some leaders, right? And so it's almost like in order to do new AI and data projects, there has to be a higher level, sometimes coming directly from the C-suite, of care and accountability to leverage this data, right? And then to have a single source of truth, if you will, about how all data is dealt with, because any data that's collected can be in the future data that is leveraged, right? So if we don't have a perspective globally as a company, as an organization, which can, let's be honest, it can take some time, right? Because companies that have their data in order can leverage data analytics and AI projects faster than a company that still has to get those things together. So data governance is huge in order to do a successful AI, machine learning, deep learning project. Would you guys all agree with that?
Yeah, and I'd love to add the importance of having clean data. So one of our recent projects, we were working on a classification model with some fairly messy data. And just by going through and kind of doing some of the classification by hand ourselves, we were able to get about a 20% gain in accuracy in our model versus what we would have been able to do with tuning. So I think that's a really good approach that we'll see more of in the future, of gains in accuracy with better data rather than better models or better tuning of models.
Right, because, and I want to add to that point, how many of you have experienced model drift, right? It's a natural consequence of running AI projects. And in production, when that model drifts a little too far, you can have bad things happen, right, over time. And then we have to really go back and peel back that off that lid and really see what's going on in there. And sometimes we don't discover that until it's 2 or 3 months out, right? So when models drift, things can go bad. To your point, Colleen, and actually, the better your governance policies are, the better your outcomes will be in the use of that data, right? So a lot of, back in the Hadoop days, Tableau days, and I understand those are still out in the wild, but before all the platforms came along, right? All the analytic platforms came along, the Snowflakes of the world, the Alteryx of the world, and I don't mean to promote any brand here. I'm just saying, before those SaaS products came to market, man, it was really a wild, wild west, and every executive knew, all right, we got all this data, let's start doing some projects. And really, AI got a bad name, and I hate to say it that way, but it got a bad name because the reality was a lot of companies didn't know how to organize and utilize that data. Would you guys all agree? So AI was relegated to the science project instead of a true business function and an outcome driver for an organization. It was kind of like cool and kitschy, but we're not going to throw millions of dollars at this experiment just to find out and see. So the point here is your data governance and provenance and all those things are extremely crucial in order to run a successful project. All right, we're gonna go to another set of questions here, and it's really about the tooling innovations. Okay, so what are some of the tooling innovations we can expect to see? NLP, image, network data, those types of things. Anybody want to take that?
I can speak a little bit to NLP and network data. Some of the
Okay.
trends that I've seen really involve being able to parse out meaning from text data. So our problems so far have mainly been more of the text matching sort of thing, but in previous positions, the meaning behind statements. So I've worked with chatbot data before, and being able to understand what people actually mean rather than just the words that are coming through was a big problem and a big challenge. Being able to really understand the meaning behind things, the semantics. And I think we'll see more of that detection of sarcasm, kind of reading between the lines of the text, I think is going to be really important, especially in marketing applications and customer service. Understanding what customers are exactly saying rather than just what the literal words are is going to be important going forward, I think.
Yeah, no, I definitely would agree. I know algos are being generated around emotional AI and really modeling after how our brains work. I mean, how we think and picture and how we image ourselves, right? So regardless of the use case, whether it's in a kind of a natural language processing kind of thing or a vision play, you know, it's a lot going on that's being modeled after our own neural networks. If you haven't learned that term, go look that term up. Because a lot of algorithms, convolutional neural networks, a lot of algorithms are built around the neural networks themselves. And then when you look at the building an emotional imprint on those neural networks, then we start to your point, Colleen, we start to get into sarcasm. We start to get into the nuance of language, right? Which, you know, as we look even 20 years ago from a dialer, you know, we heard this very robotic voice or this very robotic phrase that we all knew, okay, this is a machine. Man, it's getting pretty close. I mean, with Sophia and things like that, obviously, you know, I'll just say this really quick. Did you guys know that Sophia was the first AI to be given citizenship in the world? Think about that. I don't want to make that point small. This is a very, very transformative and big statement. An AI in a particular country has been given citizenship. Okay, so we're getting better and better, guys. It is going to change the world. The question is, are you going to get on the boat or are you going to wait and watch from shore and see what happens? Okay, no, there's a lot going on, and I know everyone that's on this call is really interested in this topic, so I'm just trying to sprinkle in things that are out there in the wild. All right, so anybody else want to take that in terms of tooling innovation? If not, I'm going to go to the next piece here. All right, so
we are also something on top of what Colleen said. We are also looking at different tools that deal with ethical AI and secure AI algorithms. And I was at another conference where I think there's already innovation happening to ensure that there is social fairness in machine learning predictions. That is, whether one category of person is being weighted unequally in different scenarios, whether it's recruiting or something else, and how to actually, you know, debug and deploy ML models with similar countermeasures, you know, against insider and some cyber threats in traditional software. So there's also a lot of research done, you know, starting from really large companies to startups to secure AI and create more transparent model architectures and increase intuitive and understandable ML models so that we can make sure that AI meets the relevant regulatory requirements, going back to data governance, and deal with better deal with a much more intuitive fashion when it comes to GDPR, CCPA, FCRA, ECOA, whatever other regulations exist in different regions. So we could go into multiple dimensions on this question if you need.
yeah, well, to that point, you know, as we talked about tools and platforms and technologies, like, you know, what advice would you three give maybe to someone on this call that is looking at a career in data science? they're looking to grow their career perhaps, or look to go to the next level. And to be interesting, I think it's important to know what's cutting edge and what's coming forward, right? Because AI is already cutting edge, but there's a new edge on that edge, right? Because it's so fast, and not just from the algo's perspective, but just the movement of the industry. As we all know, today, most engineers in some capacity are using API, right? No one's just building in a bubble in a black box by themselves anymore, and then there's going to be this output and this great, outcome from that output. We all know that we're connecting to APIs, and we're doing all this, restructuring of how we organize and build, right? And a lot of that is happening cloud native or cloud hybrid cloud and all those types of things. But my question again is if someone is looking to get into the field or further their career or something like that, what would be some of the best advice you guys would have for them? And I love to hear from all three of you. That's what we can share.
I can start out quickly. I think one of the things that I've learned in my career is really the importance of understanding the industry and the business. The tools change in my experience every couple of years. I am switching tools and platforms and technologies, but the point of doing data science is really to solve a business problem and bring value to customers or to the business. And if you can understand that in your industry and be able to keep up with these tech tools, you'll remain relevant as new technologies come. And as these platforms that automate parts of data science come, you'll still be able to really talk to the why of the data science project and how to leverage these results for increased revenue or helping with the customer problem.
That's great. Thanks, Colleen.
Yeah, I want to echo Colleen's statement. Focusing the tools change, right? Don't get too hung up on those tools. Abstract away from that and start thinking about problems and what tools those problems solve. Because there's other tools that are going to evolve or sort of be better than that one, and you want to understand how similar, how is it different, and sort of start to understanding that, and you start to focus on a problem versus a tool or just a particular solution. And so that point, I really don't want that to go away, because that's something that I've learned quite a bit in my career too so far. So that's a piece that I'd focus on. The other piece I want to say is, you probably hear this many times, right? Data science means a lot of things to many people, different industries, different companies look at it and practice it and implement it differently. But fundamentally, like Colleen said, right, you're solving problems. So starting to understand what problem space you're operating in, and making sure you're focusing on always this principle of begin with the end in mind, right? What are you trying to solve for? What are you getting out of it? If you can start to focus on that, then you'll start to really get a sense of what's really happening. And then the other thing I'd say is looking at fundamentals, making sure you understand what's operating under the hood of whatever it is that you're doing, right? If it's as basic as some linear regression, understand what that is, right? If you're looking at neural networks, yeah, that's great, but something come up, but understand what is going on. And I think those are the things that I'd say as you're looking to grow your career in data science. Understand where you want to go and understand what is going on, what tools are there, but not just the tools, but understanding what problems those tools solve.
That's great. Thanks, Joseph. Akshay?
Yeah, Colleen and Joseph touched upon some of the points that I was trying to emphasize. Yes, to business acumen. Data scientists are operating in a world where you're not given a traditional problem and which is super defined, and then you have to go and execute on it. Data scientists are operating in a world which is more abstract. Sometimes you will have to understand the business and get the basics of the tech and marry them both and create your own solutions towards problems. That's why there are so many languages and different libraries that are coming up every day, which could be leveraged by other data scientists. That kind of innovation is kind of slower in other spaces like cloud or natural software languages, because there's so much space for innovation. If you get your basics right, and if you're willing to constantly learn and adapt and question yourself, what could I do differently? How could I make things better? You can probably go into, advanced machine learning or recommendation engine, deep learning, computer vision, or NLP that we touched upon, model deployment, whatever it is. There's several different dimensions where you could go and be an expert at. And incrementally, I've observed data scientists becoming better and better at the art of storytelling when it comes to business, leveraging the data that we have so that other people can understand why are we trying to solve this problem at this time. And sometimes, like, I talked about responsible and ethical use of AI. We kind of answer some of those questions that we didn't even know that we had. We didn't even know we had these problems before, but technology helped us understand that. Humans who are data scientists helped us understand and create those solutions in problem spaces that did not even exist. So be prepared to drive innovation that could be leveraged like a decade or 2 decades later.
That's awesome. Thanks all three for your input on that. I like to also add a perspective here that, if you're a new data scientist, maybe just graduated, maybe just got your PhD, whatever it is, I want you to think about it this way. The more you have understanding about how to contribute to the efficacies of what the problem is, and solving that problem, that, back in the days, it's like, hey, we're going to hire data scientists, we're going to spend $200,000, we're going to put that guy in the closet and nobody can talk to him. Guy or girl, I'm using that word interchangeably. We're going to put that person in the closet, and then no one can talk to the data scientist because they're a protected resource. Leave them alone, right? And now I think data scientists are peeking their heads above their laptops and their machines and being able to articulate the business value from your seat as a data scientist is very important, because your leaders are going to want to understand not only the problem that you're working on specifically, but your understanding about how that impacts the customer, how that impacts the business, and what it's solving, right? So it's kind of a culmination of what all three of you are saying, but I think specifically to the point of if you're new. If you're new in this space, gone are the days where someone's just going to give you a machine and you're going to go ahead and model and do all of that, and then 3 years later look up and we're going to all celebrate. That doesn't happen anymore. Okay, those days are long gone. Okay, and the companies that are still doing that, they're probably still waiting to see an ROI on those investments. So just keep in mind that you're going to be thought of as a leader, not only in the data science specifically, but a leader in understanding the problem and how your knowledge is contributing to solving that problem. Would you guys all agree with that? Awesome. Yeah, so keep those things in mind. All right, so here's what, go ahead. Oh, I thought you said.
I was just saying right on. I'm going from mute to unmute, and so there's a lag, but you're spot on.
No worries. Okay, cool. So I know, just in the interest of time, we want to open it up to some Q&A. And so I know there's some questions that have been pre-submitted. And so what I'd like to do is maybe have Emma or Kara jump back to help us look at some of those questions. I'm going to start us one. But Kara, as you see those come in, I'm not looking in chat, but as you see those come in, you can just say them, right? Just come on and share them with us, because I can't see them right now. The first one I want to ask is data science moving to a cloud-based environment? Anybody want to take that? And maybe if it is, why?
I'll start with that, I guess. I've seen a lot of cloud needs, particularly as companies become multinational and deal with these different data governance laws. It's a lot easier to do siloed on a cloud platform rather than building your own custom security systems and data governance within the company. And I think as we get different regulations in different places, we're going to see more on cloud.
Got it. Thank you for sharing that. I agree. Absolutely.
Yeah.
Anybody else have perspective?
Yeah, I would add that, I think like flexibility. When I think about data science, and we talk about problem solving earlier, you want to spend your time focusing on what that problem is and how to solve it. And a lot of times, not so much on the tooling and infrastructure that comes with helping you to solve that problem. And so moving to cloud-based environment enable you to kind of abstract away some of that problem. Not saying you're not necessarily concerned, because then you have to have folks in your organization who know how to set that stuff up, if it's VM in a cloud-based environment, or you're using a PaaS version or versus IaaS, and I mean platform as a service or infrastructure as a service. So I'm not just using those acronyms, but like just sort of understand. So it allows you the flexibility to kind of focus on the problem as opposed to getting the infrastructure set up and try to get it working right. And so you can spend more time focused on the problem. So I think in that regard, that's where I see the trend is in the environments I've worked in. That's what I feel is solving, help us kind of like abstract away that piece so I can focus on my team on really like solving the problem and sort of articulating that to our business, what else we can do and where we're adding value.
I'd like to add to what
Thanks, Joseph.
Colleen and Joseph just mentioned. Earlier, like a couple of years ago, when cloud computing technologies were not that advanced, the data scientists at that time would have to, whenever you want to perform analysis on a new set of analytics or to work on some kind of a refreshing algorithm, you would have to take the data, move that into a local machine from the database, and then proceed to work on it and all of that good stuff, right? So data became more and more evident, and then you went from a couple of 100 gigabytes to petabytes. So think about moving all of those petabytes of data into your home or PC again and again. This kind of challenge became more and more evident. So the cloud computing companies realized that, hey, the data usage is gonna go more and more. So let's address the problems of data scientists. So they came up with, different kind of capabilities to handle the structured information like stock information, geolocation, whatever, or the unstructured information like social media messages or videos or images and all of that. So as data scientists, like Colleen and Joe mentioned, you would have to, you don't need to like worry about how to work with many different tools. There's Hadoop, MapReduce, Pig, Hive, Mouth, all of these functionalities that are compatible with the cloud server, whichever cloud server architecture you decide to handle. The data scientists can also leverage the storage capabilities that are handled by the owner and the server, and leverage the server architecture or the infrastructure and create data backups. You don't need to worry about secure data storage or losing your information. And it's cheaper, because cloud innovation got more and more competitive. It's more cheaper to host the data and pay as you go and all of that. And it's becoming more and more language agnostic. So you don't need to think about installing a ton of tools or other frameworks like, hey, do I learn more technology related to data science or cloud? It's not becoming that burdensome as we go ahead. And by 2025, the idea is to make it more seamless. So that's just something that I wanted to add.
No, that's great. Thank you for sharing that. This is a unique, well, it's kind of a unique question that I'm looking at here, and I want to take a first stab at it, but I want you guys to weigh in on this. It's unique because the question is, where does AI fit into the traditional IT organization? My perspective, and I'll share this at first, is if we're talking about a traditional IT organization, meaning networking, infrastructure, the SDLC process, agile methodologies, like, building software, if you will. If we look at that from that lens of a traditional IT organization, it's varied. It exists in different places. So I've seen teams where the data group reports directly up to the C-suite without any leadership in between. It depends on if it's a flat organization, if it's a large organization, a small organization. Are you 5,000 people or are you 40 people, right? And so because a lot of folks are leveraging SaaS models to do data science today, that you got to think about what is the outcome, and why are you doing this project, and there's a fly. That was random. And so essentially you got to think about what's the outcome? What are you trying to do here? And then that will probably tell you what stakeholder is going to be attached to that problem, if you will. So AI as a whole, I would say, doesn't necessarily exist in any particular business unit. It just really depends on the organization, because some are very highly innovative driven, and so they might put those innovations at, where IT is a profit center, not a cost center, right? It's not just keeping the lights on, it's actually driving the marketplace. So you got to think about this question in terms of who are you serving, what's your client, what's, not your client, what's your customer environment, all those types of things. So anybody else want to take that on real quick?
I can add on to what Eli said. It's whether it's banking or whether it's high tech, people are using AI to automate some things and solve those problems where it would take thousands of months or days or whatever for humans to solve the problem. An example I would like to give was last year I was talking to this banking company. Was using AI to translate all of the documents and contracts written by different people in their own native languages, and create contracts and store them into the cloud. For that, you don't need, it would take them millions of dollars to hire translators who also know finance and legal and train them on how to read those contracts. And then, if there's some small problem or a mistake that happens, it would be like really bad for the banking industry, because there'll be lawsuits over lawsuits. So they are leveraging AI in a traditional banking company to actually solve this particular problem. And they spun up their own AI and innovation center that never existed before. They were a couple of finance folks working on Excel, and they went from that to this, right? Same thing with ad tech. You want to understand the emotions of users who are watching your ads. Are they actually buying it because they relate more to the ad, or is there something that you're doing with that appeals to that set of people in that locale more? And then they translated that into return on investment and revenue generation and all of that. So AI is becoming a part of so many businesses: banking, retail, e-commerce, streaming services, or anything else. It's just how you want to operate that and use that into your systems.
Yeah, there's a reason why we're calling this the fourth industrial revolution. Guys, pay attention to this this space, because to your point, it's very pervasive. And I mean, as you see with Joseph working in agriculture, or Colleen working on nuclear reactors, or Akshaya working at Netflix, and I'm sure, first of all, Netflix, you guys have a great recommendation engine, right? And I would say it's better than a lot. And no, I love everyone, but I would say it's better than a lot, because you guys are probably heavily invested there, and it works for the most part, right? And so kudos to Netflix on that. But the point is that you guys, we have to think about this entire space differently. So does AI fit in a particular business cost center or profit center? Maybe, but you have to think about this in terms of, what are you solving? And is there a keyhole? Is there a key stakeholder that's tied to wanting to have, and oftentimes it's a stakeholder in the business that's tied to wanting to see this thing happen, whatever it is. So just think about, this is not AI is so pervasive that we can't give you a pat answer and say, yep, AI fits right here. Data scientists fit right here. That doesn't exist anymore. So, and it's moving so fast. This question, and I know we're getting to the hour here, but this question I think kind of parlays into what we were just talking about. The question is, how do you set standards for data at the C-suite level, especially in a company that collects and processes multiple types of data in a variety of formats, file types, etc.? We see a bottom-up requirement growing with executive guidance, but executives can't set data standards because of a tech literacy gap sometimes, and subordinate units will fight to avoid governance. This is a big question, but does anybody want to take at least a part of it, or try to address it in a few minutes?
One thing that I've noticed is that it's helpful to have either a head of data science or a chief data scientist within the organization who can kind of bridge the gap between the tech team and the C-suite to kind of set this up. And with some of the consulting that I've done, it's really important to make sure that a startup or a new organization starting to collect data has some of these things in place before the data projects and the data science projects start. Being able to bridge that gap and make sure that the data is there is really important to getting started in data science.
That's good. Yeah, and as we look at setting the standards, that part specifically at the C-suite level, having key stakeholder ownership, whether telling to your point, some companies can't afford a C-level data-driven leader, right? That's just the reality. Depending on the size of your enterprise, that's just the reality. So then what, right? So I think it's back to setting the standards. Sometimes you need to look at AI and AI projects. It's almost like a center of excellence and building a team of leaders that all have common interest in the outcome, right? Because if you don't have one champion leader that can set the standards, the governance policies, and all this kind of stuff, it's going to be wild, man. It's going to be wild. So I would highly recommend if you're looking at your C-level and trying to guide them, oftentimes it's a guiding up and making sure they understand what this is going to be. Again, back to the outcome. Think about this in terms of formulating a group of colleagues that have a part at some capacity, right? Have a part in the desired outcome and its effect on the business. So if you have people that are involved in that chain, then there's a group accountability to seeing that thing happen, and it'll have more legs in the organization. And then you can create through kind of center of excellence, you can kind of create, if you will, a group of people that are very, very passionate about this project or idea or whatever it is that you're building or doing. Because oftentimes if it's one person that's making the decision on that, and it happens to be a chief, then great, because they can downstream all those details. But if you don't have that, then oftentimes you're managing up what those expectations should be and why, and you have to back that, and attribution and all those types of things will have to come as a result. Great group of questions here. I think because we're 2 minutes over the hour, I'm going to go ahead and hand it back to for just closing thoughts and remarks. But I'd just like to say thank you, three, for being a part of this panel. It's been great to get to know you and chat with you a bit. So thanks everybody for joining this call. Emma.
Thank you.
Hi, I'm back.
Or,
thank you guys.
Kara, I don't know who's.
Yeah. Thank you guys so much. That was such a good conversation. I feel like we could just keep going all day. I could listen to you guys talk all day. I'm sure everyone feels the same way. So with that being said, if you did submit a question that maybe we didn't get a chance to get to, I'm sure our wonderful speakers and panelists would love for you to connect with them on LinkedIn and shoot them your questions, and we can get some conversations going offline about that. Similarly, I would love to connect with you guys as well. So if you guys are interested in learning more about Tech in Motion, how you can get involved, or even if you're searching for a job, please connect with me on LinkedIn, and I would just love to hear from you and get more connected. I hope to see you all at our next event coming up soon in the next few weeks here. And thank you again to our wonderful panelists and having this great discussion with us. We'll see you all next time. Thanks.
Thanks so much.
Thanks
Bye,
so
everyone.
much.
Take care.
Thank you. Bye.
Thank you.